Okay, so let's look at how to solve this problem. So the first thing we want to notice here is how we're actually going to take this sort of conceptual problem and turn it into a mathematical one. So we have a proton orbiting and we want to change, that's a bad orbit, we want to change the point mass to a point charge without altering the orbit of the proton. So what affects the orbit? Well, we've already got a speed, so it's not going to be changing speeds because it's in a circular orbit. All that determines how circular the orbit is and what the radius is the speed, but that's held constant, and the force, the inward force applied by the point mass or the point charge. So the key is we want the force to remain the same. Well, let's look at how to do that. We have two equations here. We have the force of gravity is g m1 m2 over r squared, using our Newtonian equation here. And we have the force by electrostatic forces, or the electromagnetic force, is k q1 q2 over r squared. Okay, so let's look at what these numbers are. Well, m1 is going to be our thing it's orbiting around, which is 100 kilograms. m2 is going to be the mass of the thing orbiting it, or the proton, which is going to be, I have it written over here, it's 1.67 times 10 to the negative 67 kilograms. 10 to the negative 27 kilograms. Okay, now what's g? Well, g is just a constant. It's up here. It's 6.67 times 10 to the negative 11. And lastly, r squared is just going to be 0.001 squared. It's going to be a lot of zeros. Okay, so we can now calculate the gravitational force. You can do the math yourself, but it comes out to be about 1.11 times 10 to the negative 29 newtons. So it's a very, very small force. Now let's use this equation over here. So now we're not solving for the force because we already know the force. We want to keep it the same, and so we want 1.11 times 10 to the negative 29 newtons. Now what do we know and not know here? Well, we know k. K is over here. It's 8.99 times 10 to the 9. We know q2. Remember, q2 is the mass of like the orbiting thing. In this case, the proton. It's 1.6 times 10 to the negative 19, roughly. Coulombs, I should say. And we know r squared. So r squared is again 0.001 squared. So we really just solve in reverse here. We're looking for q1, so we multiply both sides by r squared, and we divide both sides by k and q2. I won't, the equation is fe r squared over k q2 equals q1. And you can plug in all the numbers here, and you get a final answer that the charge is going to be about 7.75 times 10 to the negative 27. However, remember, we always want to charge for orbits, we always want to charge pulling in. And so we want the proton to be attracted to the electron, and so we want, or to the point charge, so we want the point charge to be negative. Now notice, this charge is really small. It's a tiny, it's negative 27. Whereas the mass that it was orbiting around previously was pretty significant. It was 100 kilograms. It wasn't nearly as small as this. And that's because of two things. First of all, that's because the proton's charge is much bigger compared to its mass. And it's also because the gravitational force is really weak compared to the electromagnetic force.